Welcome back, everybody. This is our first class in JEE Mains previous year questions for chapter Moving Charges and Magnetism of class 12th. Before this, in this JEE Mains previous year question series, we have solved questions for previous chapters for class 12, 1, 2, 3, and all the remaining chapters of the class 11th also are available as videos. We have also started similar playlist for NEET previous years, and those videos can be found on our YouTube channel's playlist section. Again, if you found these videos useful, helpful, then do press the like button, share them as much as possible, and subscribe to our channel. It helps a lot when you share and subscribe. And if you want to support us financially, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you can. Any small amount, maybe, however small, is will be highly appreciated. So with this, let's start today's video with questions. So let it just slightly pen thickness first. Here we have an electron moving in x direction, positive x direction with velocity. So velocity is mentioned 6 into 10 raised to power 6 meter per second. It enters in a region of uniform electric field. Field is given, and velocity of electron is in positive x. So I electric field is in positive y. So 300 volt per centimeter into J. The magnitude and direction of the magnetic field set up in this region such that electrons keep moving along the x direction will be. Now we know that when the velocity is given by E by B, where E is electric field and B is magnetic field. Actually, these are magnitudes of their respective fields. And this formula is valid when both of the electric and magnetic forces are balanced with each other. We can also find out like it's like that suppose electric field is acting here, electric field is acting in the y direction. So suppose this is our coordinate axis, this is x direction, this is y direction. So here electric field is acting something like this, and electron is moving like this. This is the motion of electron. So force on electron here will be downward. Force acting on the electron will be downward, and that is given by Q times E, charge of the particle into we can say electric field. Now, as asked in question that electrons should move in the straight line, we have to apply magnetic field such that electrons should move in the straight line. So first of all, the force by magnetic field should cancel out this force by electric field. So force by magnetic field should be like this. So magnetic force must act along a positive y direction, and magnitude of we can say magnetic force is given by QVP. And if we equate both of these, QVP is equal to QE, and we get the same formula that V is equal to E by B. From this, B comes out to be E by V. So first let's calculate the magnitude for B, and then we will move to direction. So magnitude of electric field is 300 volt per centimeter. It's volt per centimeter. We have to convert into volt per meter. So 300 volt centimeter is 10 raised to power minus 2 meter. So it can be written as 300 into 10 raised to power 2 volt per meter. So electric field will be 3 into 10 raised to power 4. Velocity is 6 into 10 raised to power 6. So we get half into 10 raised to power minus 2, or we can write it like this, 5 into 10 raised to power minus 3. That will be the magnitude of electric field or magnetic field, sorry. So option A get cancelled and option D get cancelled. Now coming to the direction. So now direction of magnetic force is given by Q into V cross P. This is the basic formula for magnetic force. Now we know that direction of force is in positive J direction. So we have a J here. Charge does not have any direction. Now velocity is in X direction. Velocity is in X direction. So we have I here. Now we have to decide value of B such that I cross that value we get J. And we know that I cross, we can say, sorry, K cross I is equal to J. K cross I is equal to J. And if we write I cross K, it becomes minus J. So what we can do here, I cross minus of K will be minus of J, oh sorry, plus of J. So hence direction of B should be minus K, or we can say negative Z direction. Option B will be the right answer. Moving to the next one, a particle of charge Q and mass M moving with velocity negative vi means in negative direction, negative x direction towards a large screen placed in the yz plane at a distance t. If there is magnetic field B is equal to B node K, the minimum value of V for which the particle will not hit the screen. So let's first slide it and draw the coordinate axis. Suppose these are our coordinate axes with this being x, this being y, and this being z. Now we have a screen, large screen, placed in the yz plane at distance d. So suppose initially our particle is at this point and this distance is d. We are considering that screen is placed at the origin and this distance is d. But our charge particle of charge q and mass m is at here. And we have a screen here, so let's draw the screen. Okay, we have to make it slightly. Okay. So suppose this is our screen in YZ plane. Hopefully you able to visualize it in YZ plane. This screen is in YZ plane. And at D axis, I think we have to move it slightly so that it will be better visible. So I'm going to pause the video here so that I can adjust the diagram. I think now it's better that screen looks properly in the YZ plane and the particle at a distance D. Now electric field is in, oh sorry, magnetic field is in K direction. So we can say in Z direction. So we have a magnetic field which is acting like in this direction. So we have to decide value of velocity for which particle will not hit the screen and particle is moving like this. The particle is moving in the negative x direction. There is magnetic field in the we can say z direction. So we have to find value of velocity such that it does not hit the screen. So we know that force on a particle in magnetic field is given by Q V cross B. So first of all, let's find out the direction of the force. So charge is as it is, velocity is in minus I, and magnetic field is in Z, so K, and we have I cross K. We know K cross I is J, so it is I cross K, so it will be minus J into J, so this will be Q into J. So the force acting on the particle will be something like in the upper direction, the y direction. So force, we can say magnetic force will be on the upper direction. Now, if we want this particle to not to hit the screen, what will happen? As this particle has velocity in x direction and force acting in the y direction, so it will acquire we can say velocity in the both in x and y. It will have velocity both in x and y, and when a magnetic force act on a particle, it starts rotating in a circle. So eventually this particle will start rotate something like this, that if there was no magnetic we can say no if there were no magnetic field, then this particle should have moved like in the straight line. But as there is magnetic field, so there is upward force on it, this particle will start rotating like this in a circle. So what we just want, that when this particle is rotating in the circle, what will happen, that when this particle is rotating in the circle, its radius should be smaller than this distance d, so that it's keep on rotating in a circle but never touches the screen. What we want, that when this particle is rotating in the circle, its radius should be less than the distance d. So its path should look like something this. Its path should look like something this. That its radius is either equal to this distance d or less than this distance d. So for that we know that r radius is equal to mv by qb, mv by qb, and using this we can find out that velocity will be qbr by m, and r minimum value of r is maximum value of r is d, so it will be qbt by m. That is option c will be the right answer. Moving to the next one. Charge particle carrying charge of 1 microcoulomb is moving with velocity. So charge is given, velocity is given, external magnetic field is given, where the particle moving, then the force on the particle. So we have to find out simply force on the particle, and that we can find out. Force on particle is given by Q V cross B. So what we can do, the value of charge is 1 microcoulomb, so 1 into 10 raised to power minus 6, and here we will do matrix because we have to find out cross product. So I J K, first we have to put values for velocity 2 3 4, and then for magnetic field it has a 10 raised to power minus 3, so 10 raised to power minus 3 will stay outside, and we have here 5 3 minus 6, so it will be 10 raised to power minus 9 into here minus 18 minus 12 minus 18 minus 12 of I, negative of j into minus 12 minus 20, positive of k, we will have 6 minus 15. So 10 raised to power minus 9, we have here minus 30i, here we have 32j positive, and here we have minus 9k. And we have to represent it in the form of f into 10 raised to power minus 9. So 10 raised to power minus is here, and this will act as f. So value of f is option B. Moving to the next one. Beam of protons with speed enters in uniform magnetic field of magnetic field value is zero point 0.3 Tesla at angle 60 degree to the magnetic field. The pitch of the resulting helical path of proton is close to. So we have to find out pitch. So when we can say when there is a we have two components of a velocity. Suppose this is the direction of magnetic field. Let me draw. Suppose this is magnetic field in x direction, assuming. So this is magnetic field. And we have a particle entering in this magnetic field with certain velocity at certain angle. So this is its initial velocity. So we will have two components, one component in the parallel to the magnetic field, that will be v cos theta, and one component to perpendicular to field, that will be v sine theta. Now this v sine theta component will decide rotation. So rotation will be decided by v sine theta, and horizontal movement or parallel movement will be decided by v cos theta component. Now when particle is rotating, it will have some time period, and that time period is decided by this v sine theta component. So we know that rotation radius is equal to v into perpendicular velocity by qb. So here radius will be m v sine theta by qb. So this is the radius, and using this radius we can find out time period. Now time period will be, as we know that in a total circle, time period will be given by total circumference, that is 2 pi r by velocity. So we have to find out for r by v from here. So from this expression, r by v will be m sine theta by qb. Using this, 2 pi m sine theta by qb, I think, or we made some mistake. Yeah, here we have a perpendicular velocity, and perpendicular velocity is v sine theta. So sine theta will stay here. So time period will be 2 pi m into divided by qb, and we have to find out resulting pitch. Pitch is the distance traveled by the particle in unit time period or in one rotation. Horizontal distance traveled by the particle, or distance traveled by the particle in the direction of the field, in the direction of the magnetic field. Here time is 2 pi bm by qb, and horizontal velocity or velocity parallel to magnetic field is v cos theta. So pitch will be 2 pi m by qb into v of cos theta. Putting these values, we have 2, 3.14, mass is 1.69 into 10 raised to power minus 19, divided by charge is 1.67 into 10 raised to power, sorry, this is minus 27, and mass is 67, this is 69, 10 raised to power minus 19. Magnetic field is zero point 0.3 or 3 into 10 raised to power minus 1. Velocity is 4 into 10 raised to power 5 into cos theta. Cos 60 we have, cos 60 will be half. Now we can easily cancel 1.69 and 1.67 because we have to just approximate here. And this 2 again get cancelled, and we are left with 3.14 into 4, 3.14 into 4, and we have 10 raised to power minus 27 plus 5 plus 1 and plus 19 divided by 3. So this will be 19, 20, 25. So we will have 3.14 into 4 into 10 raised to power minus 2. And from this, we can write it like here, approximate it 1.04, and that will be 4.16 into 10 raised to power minus 2. So it will be approximately 4 centimeter, and we have to approximate here the close to. We have to find approximate answer. So option D will be the right answer. Moving to the next one. The figure shows a region of length L with uniform magnetic field zero point 0.3 Tesla in it and a proton entering in the region with velocity 4 into 10 raised to power making angle 60 degree with the field. If the proton completes 10 revolution by the time it crosses the region L, the length close to. So we have to find out length, and it is mentioned that proton is making 10 revolution. As proton is making 10 revolutions, it means it has traveled, it has traveled distance equal to 10 time of the pitch. The proton will be taking proton's path will be look like something like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and finally at 10th it comes out. So it has traveled uh, 10 distance 10 times of the pitch, and we know that pitch we just solved, it is equal to 2 pi m by qb. So our distance will be pitch, so 2 pi m into v cos theta. So that is equal to pitch, and we have distance traveled 10 times the pitch. So total distance or width of this region L will be 10 times of 2 pi m by qb into v cos theta. So 10 twice pi mass 1.67 10 raised to power minus 27, velocity 4 into 10 raised to power 5 into cos of theta, cos 60 is again half, and charge is 1.6 into 10 raised to power minus 19, and field is zero point 0.3. So this is exactly the same calculation which we did previously, and previously we the answer for this part, we solved this one and we got 4 centimeter. Now if you multiply it by 10, we will get 40 centimeter, and that will be approximately equal to 0.44 meter that is mentioned in the question. So option C will be the right answer. These calculations we done here in the previous question. So moving to the next one. Proton with kinetic energy of 1 mega electron volt moves from the south to the north. It get acceleration of 10 raised to power 12 meter per second square by applied magnetic field west to east. The value of magnetic field, rest mass of proton. So we have a kinetic energy, means using this kinetic energy we can find out velocity of the proton Using that velocity, we can calculate the force, and as we have been given acceleration, then we can compare those two values. So first of all, using the kinetic energy term, kinetic energy will be half mv square is equal to 1 mega electron volt. So 1 into 10 raised to power 6 electron volt. So 1.6 10 raised to power minus 19 joule. This will be the value of, we can say, uh, energy. And using this, we will get v square is equal to 3.2 into 10 raised to power minus 13 divided by m. So this is the value of v square. Now we have acceleration of 10 raised to power 12 due to magnetic field. So as acceleration is 10 raised to power 12 meter per second square, then we can say that force will be, magnetic force will be mass time acceleration. So that will be m into 10 raised to power 12 Newton. And we know magnetic force is equal to Q into V cross P. Now let's find out the direction, the angle between velocity and magnetic field. So here velocity is from south to north. So suppose this is north, this is south. We have east here and west here. So velocity is south to north and acceleration is west to east. So we have acceleration like this. So angle between velocity and acceleration of velocity and force is 90 degree. Means angle between, assuming that that our field is applied at 90 degree to the with respect to velocity, assuming this, and there is no particular component of velocity parallel to, we can say, parallel to magnetic field. The velocity is perpendicular to magnetic field. That's we are taking assumption here. So we have a force q we know, and a value of velocity we have, and mass is also given. So using these values, so force will be 1.67 into 10 raised to power minus 27 into 10 raised to power 12 is equal to q, that is charge. And charge is not mentioned here, but what we will do, we will take value by default value for charge, that is 1.6 into 10 raised to power minus 19 into velocity, and that velocity will be equal to under root of this. So under root of 3.2 into 10 raised to power minus 13 divided by the mass. Mass is 1.6 into 10 raised to power minus 27, and we have magnetic field here B. So this will go 2. On this side we will have 1.6 into 10 raised to power minus 15, and on this side 1.6 into 10 raised to power minus 19. In under root we have twice into 10 raised to power, this will be 14, 10 raised to power 14 of B. 1.6 get cancelled, and we will have here 1 by, oh sorry, 10 raised to minus 15 by 10 raised to power minus 19 root 2 into 10 raised to power 7 is equal to P. So we will be left with 1 by root 2 into 10 raised to power, this will be minus 22, and this will be minus 19, so plus 19. So 10 raised to power minus 3, minus 22 plus 19 minus 3, and 1 by root 2 is equal to 0.0707 into 10 raised to power minus 3, and this will be, we can say, 0.71 millitesla, and that is option A will be the right answer. Moving to the next one, particle having the same charge as of electron moves in a circular path of radius under an influence of magnetic field. So radius and magnetic field we are having. Electric field makes it to move in a straight path when the mass of the particle is So first let's write down all the variables which are given to us. So radius is 5 centimeter, 0.5 centimeter, so 5 into minus 10 raised to power minus 3 meter. Magnetic field is, sorry, B is 5 into 10 raised to power minus 1 Tesla, and charge is also already mentioned. So charge is 1.6 into 10 raised to power minus 19 coulomb. So we know that radius is equal to mv by q, and we have to calculate mass here. So we have given radius, we know, velocity we know, and charge we know, and I think all the values we know. So what we have to do? Okay, v is not given, sorry, v is not given here. So we have r, we have q, we have b, and v is not known to us, and mass we have to calculate. And it is also mentioned that if electric field of 100 volt per meter is applied, that charge particle moves in straight path. So now we know that when a charge particle is moving in the straight path, then its velocity is given by e by b. So we will use this relation here, and so r will becomes m e by q b square, and using this m will be equal to r q b square divided by e. Putting values, r is 5 into 10 raised to power minus 3, q is 1.6 10 raised to power minus 11, and b square will be 25 into 10 raised to power minus 2 divided by electric field, that is 100 volt per meter. So what we will have, 125 into 1.6 into 10 raised to power minus 22 and minus 24 and minus 2 minus 26. So now multiplying these two, we will have some value. Suppose just I am just approximating. Suppose it is 190. So we have 190 into 10 raised to power minus 26. It's approximation, and we can write it like 1.9 into 10 raised to power minus 24. We will at least get three-digit value from here because both of the numbers are greater than 1. So our answer should be in 10 raised to power minus 24, and we have only one option which has 10 raised to power minus 24. So option D is the right one. Moving to the next one. Here, I think, I think here we have some portion which got missed. So we have an electron here actually. So an electron of 100 electron volt energy enters in a region of magnetic field B, that is given by this value as figure. The field extend up to between x0 to x is equal to 2 centimeters. So the field is acting between 0 to 2. The electron is detected at a point Q on the screen placed 8 centimeter from the point S. The distance d between p and q on the screen is, so we have to find out this distance p and q. So to find out this distance, what we have to do, we have to form an equation between velocity, and then using that equation we will find out the coordinates. So first of all, let's first we will do uh, what we will do here, that we will find out the coordinates of this point, that when electron is leaving this region of magnetic field, we have to find that at what point it is leaving the this region. After that, when electron leaves this region or when reaches this point, suppose this point is point A, then there is no magnetic field acting on that particle, on that electron, and it will keep on moving in the straight line. And when it is moving in the straight line, then when we can easily calculate its path using velocity, that how much distance it will cover. But till point A, from point S to point A, there is magnetic field acting on the particle, and due to this magnetic field, the particle will move in a circular path. And for that, we have to calculate uh, uh, the final coordinates of the point so that we can do further calculations. So, first of all, what we do, we focus on the slab part, and after solving for the slab part, we will focus on the remaining part. So, let's draw a slab part here. Let's suppose this is our slab. This is our slab, and electron is entering from this point S. So, when electron is moving here, we have velocity of electron in positive x direction, and we have magnetic field in the k direction, in the k, you can say in the z direction. So magnetic field is something like this. So direction of force on the electron will be, as it is electron, so minus q, as electron has negative charge, v is in I or in x direction, and magnetic field is in k direction or z direction. So I cross k will be minus j, and with minus minus we have plus j. So here force on electron will be in the upward direction. So force will be something like this, upward direction, which is already shown as per diagram. So suppose path of electron is something like this. This is the path of the electron, and this at this point electrons leaves this slab of electron leaves this region of magnetic field, and thickness is given 2 centimeter. Now we know that when electrons enters here, then it will start moving in a circular orbit, and its radius is given by mv by qp, and we will have center of its we can say rotation center. Suppose somewhere here we have its rotation center. So let's increase its thickness so that we can able to make it proper. Yes. So suppose its center, rotation center, is somewhat here. Now we know the radius, and radius can be calculated using the value of kinetic energy, as kinetic energy is equal given to 100 electron volt, so 1.6 into 10 raised to power minus 19. And we know that momentum and kinetic energy has a relation, and momentum is given by root 2 m times of kinetic energy. We can also form this relation as P is equal to mv, and kinetic energy is equal to half mv square multiplied by m divided by m. So what we will have here? We will have here half m square mv whole square divided by m. So this is momentum. So momentum square is equal to 2m times kinetic energy, or momentum is 2m times of kinetic under root 2m times of kinetic energy. So using these values, we can calculate radius. So radius will be 2m times of kinetic energy by qb. Mass of electron is, we know, 9.1 into 10 raised to power minus 31, under root, we will have kinetic energy is 1.6 into 10 raised to power minus 17, or we can write it like 16 into 10 raised to power minus 18, so that square root becomes easy. By charge 1.69, 1.6 into 10 raised to power minus 19, and magnetic field we have, that is 1.5 into 10 raised to power minus 3. 1.5 into 10 raised to power minus 3. So we will have 2 into 9.1 divided by 1.6, 1.5. From this we will have 4. Now going to 10 raised to power. So minus 31, minus 9 from here, plus 19 and plus 3, so plus 22. So this will minus 40 plus 22. We made a mistake here, a blunder. That momentum is under root 2 times. There was whole under root of 2 mke. We just took under root of kinetic energy. So it will be under root of whole. And here also we will have whole under root. So let's rub this. So this will be like this. So now we will have 32 into 9.1 under root, and here we will have 39 and 10, 49 into 10 raised to power minus 49 divided by 1.6, 1.5 into 10 raised to power minus 22. Further we can make it like 32 into 91, adjusting one more power, and this will become 10 raised to power 50, and the root of 10 raised to power 50 is 10 raised to power 25, and from here it is negative, and from here we will have plus 22 and divided by 1.6 into 1.5. Now solving all of this, what we get? We get 2.25 centimeter. This is our radius for this circular orbit. Now, as we know that in case of magnetic force, direction of force keeps on changing always. This direction keeps on changing, and due to this, the charge particles keep on revolving in a circular orbit. So, so to find this point, what we have to do, we have to find out here omega, or actually what we have to find out, we have to find out theta, that what it angle is making with respect to center. So suppose if this is center of the rotation, or this is the point about which particle is rotating, then we can draw a line from here, something like this. So what we will do here, as the particle has covered this angle, as particle has covered this angle theta, so we will find out this angle also. And we know that theta, in if omega is constant, and when omega is constant we have a uniform circular motion, theta is given by omega times t. Here we have to we can easily find out omega. Here omega is equal to bq by m, but we don't have value of time. So what we have to do, we have to find a different method to find this angle theta. So we will use some of geometry here, as let's make some points here. Suppose this is point O, this is S already mentioned, and this is A. Now draw a line from here, something like this. And suppose this is point T. Now we know that OA is equal to radius, and OS is also equal to radius. So OA is equal to OS and is equal to 2.25 centimeter. Now DA is equal to thickness of the slab. So AD or DA is equal to thickness of the slab, that is 2 centimeter. So now in triangle, DA is equal to 2 centimeter. So now in triangle, AD is equal to 2 centimeter. So now in triangle, AD is equal to thickness of the slab, that is 2 centimeter. So now in triangle, AD is equal to thickness of the slab, that is 2 centimeter. So now in triangle, ODA, in triangle ODA, we know the value of perpendicular, we know the value of hypotenuse, then we can calculate the value of theta. So in this triangle, sine theta will be equal to perpendicular by base, and perpendicular is AD, that is 2 centimeter, and base is, oh sorry, perpendicular by hypotenuse, perpendicular is AD, that is 2 centimeter, and hypotenuse is AO or OA, that is 2.25 centimeter. So value of sine theta comes out to be 2 by 2.5. Now, as we have value of sine theta here, so when particle will emerge from point A, it will go something like this. Particle will emerge from point A with this type of motion. And if we extend this AD lines slightly more, if we extend this AD slightly more, and now use some trigonometry, if this is theta, this will be 90 minus theta, this will be 90 minus theta, and this angle will be theta. So we have value of this angle theta. Now let's come back to our original diagram. We have mentioned this point as A, and let's mark some lines here. We have value of this theta available with us. This theta is known to us, and A2 we can say, if here we add point PQR, if we add a point R here, so we know that AR, distance from A to R, is equal to 6 centimeter. This distance is 6 centimeter, so base is known to us. Now in triangle A R Q, triangle A R Q, we know the base, we know the sine theta. Sine theta is equal to 2 by 2.5. So what we can find now? We can find out the hypotenuse. So in this triangle, hypotenuse sine theta will be AQ by AR. So AQ by AR is equal to sine theta. Oh, sorry, not sine theta. Actually, it will be cos theta. We have to write value for sine theta. Sine theta will be AQ by QR. AQ by QR will be sine theta, and it is equal to 2 by 2.5. Now we don't have the value of AQ, and we also don't have the value of QR here in this triangle, but using trigonometry, what we can do, we can draw a standard we can say triangle here, for which we have been given details. Suppose this is our standard triangle with angle theta, and for this we know that sine theta is 2 by 2.5, so this side will be 2 and this side will be 2.5. Then using Pythagoras we can calculate that this side will be 2.5 square minus 2 square under root, and it will come out to 1.026. So now we will have tangent theta using these values, that will be perpendicular by base, so 2 by 1.026. Now we will use tangent theta in this triangle. So in triangle ARQ, tangent theta will be perpendicular by base. So perpendicular is QR here, and base is AR, and AR is equal to 6. So QR by 6 is equal to 2 by 1.026, and using this, QR comes out to be 11.695 centimeter. So we have value of QR with us, and we have value of we have to find out value of rp also, and that can be found out using the value of rp. We can find out using the our previous triangle, as this is the value of rp. rp is equal to a and this line's distance. So suppose we mark a additional point here p, we mark a point q here. So rp is equal to aq, and this is point here q, this is point a. So aq is equal to this distance, this radius, minus od. This distance, radius minus od, will be equal to aq. And what we have solved here, what values we are available with us, we have OA available with us, we have OS available with us, that those are the radius. So yes, using Pythagoras, as we know that this side is 2.25 and this side is 2. So our base will be 2.25 square minus 2 square under root, and that we just solved here, 2.25 minus 2 whole square, that we just solved here, and it will be 1.026. So this will be 1.026. So our AQ will be radius minus 1.026. So that will be again PR. PR is equal to AQ is equal to radius, that is 2.25 minus 1.026, and that will be equal to uh, subtracting it. So it will comes out to be 1.224. So we have value of PR, we have value of RQ. RQ is equal to 11.695. So RQ is equal to 11.695. So PQ, the distance that was asked, is just a sum of both of these, and adding both of these we will get 12.92, and our best match is option D according to available option. So option B, sorry, according to the available option. So let me revise this whole question again because it got slightly haphazard whole process. So what we will do, initially we will do calculation only for the slab. When particles enter in the field, it will start rotating in a circular orbit, and it will leave at point A from this thickness of slab L. Now, when it leaves at point A, it will make some angle theta with its center of rotation about which it was rotating. So we will find this angle theta. For that, to finding out this angle theta, what we will use? We will use trigonometry. First, we will calculate radius, and this thickness is 2 centimeter given to us. Now, using this 2.25 value and 2 value, we will calculate its base and we will calculate this value of theta. Now, if this value is theta, then this value will also be theta. And now coming to the second part of the diagram, using this value of theta and using this value of QR, which is given to us, that is 6 centimeter, we will calculate the value of QR. And that value of that PR is equal to AQ, because these points are symmetric to each other. So it is equal to AQ, and AQ is equal to ds, and ds here is equal to radius minus OD. OD is equal to 1.026, radius is equal to 2.25. Subtracting these values, we will get PR, and adding these value to PR and RQ, we will get the final distance, that is 12.92. And with this, we end this video here. Hopefully, whatever we have covered in this video is helpful to you. Again, if you have any doubts or suggestion, you can put them in the comment section. I will try to answer them or implement them. Again, if you like this video, then do press the like button, share it as much as possible, and subscribe to our channel. And also, if you want to support us financially, you can scan these QR codes in front of your screen and donate us with whatever amount you want. Even a small amount will be highly appreciated. So with this, again, thanks for watching, and we will meet in next video.